It was in 1935, nearly 100 years ago, when Einstein first mentioned spooky action at a distance, what we now know of as quantum entanglement. Quantum entanglement is an aspect of quantum mechanics, a physics theory that describes the behavior of atoms and smaller particles such as photons. This behavior can be described, unlike the traditional orbiting model you may be familiar with, by a wave function, which determines the probability of the particle being found in a particular configuration. This configuration can be determined by the angle at which you measure the particle, and then the particle will either be in that direction or exactly opposite. It's important to note that before you measure the particle, you can't know or predict what configuration the particle is going to be in. Quantum entanglement is when two of these subatomic particles can both be described by a single wave function. This means that if two particles are measured at a vertical angle and they're entangled, one will be up and the other will be down. The amazing thing is that entanglement does not depend on the two particles being close to one another. As long as they don't interact with anything else, they can be any distance apart. This is why Einstein labeled it spooky action at a distance, because it invokes the possibility of information traveling at a speed faster than light. This does not violate relativity, because the only thing being passed is the internal quantum state. Entanglement does have applications in upcoming technologies like quantum computing. What's going to be really interesting is if we can somehow utilize quantum entanglement to send and receive information at a speed faster than light.